In this video, we're going to do the fourth example of real-world applications of the normal distribution. We're told a machine dispenses liquid into plastic cups in such a way that the volume of the liquid dispensed is normally distributed with a mean of 120 ml. The cups have a capacity of 140 ml and the probability that the machine dispenses too much liquid so that the cup overflows is 0.01. In part A, we need to find the standard deviation of the volume of the liquid dispensed, and in part B, we need to find the probability that the machine dispenses less than 110 ml. Okay, so let's write this up, and we can say volume follows a normal distribution, has a mean of 120 ml, and a variance now of sigma squared. We're trying to find the standard deviation. The standard deviation is sigma, therefore the variance is sigma squared. Let's consider the first bit of information that we've got. The capacity, the cups have a capacity of 140 ml and the probability that the machine dispenses too much liquid so that the cup overflows is 0.01. We can write this up now and state the probability that the volume is greater than 140 ml is going to be equal to 0.01. We want to convert this to the standard normal. We've seen it in our previous work that the standard normal can be given as Z is equal, and in this case, V minus mu divided by sigma, or V minus a mean divided by the standard deviation. So let's make that substitution. We can now say the probability that Z will be greater than 140 minus the mean, which is 120, divided by sigma, which is the standard deviation, will be given us 0.01. So essentially what we're going to have now, if you want a graphical representation of it, is a small sliver here that has an area of 0.01. So once we've converted this, we're going to have this area right here. Now 0.01 can be found on our percentage points chart. So if we look that up, then we can simply convert this. So let's go and look at that value and then plug it in. So we want now 0.01. So 0.01 is just here. So we get 2.3263. So what I'm now going to say then is 2.3263 will be equal to 140 minus 120 is going to give me 20 divided by the standard deviation. If that doesn't make sense to you, please review the videos prior to this. So now we're going to have 20 divided by 2.3263 will be equal to the standard deviation, which is sigma. All I'm going to do is plug this into the calculator and then store it for the next question. So let's do that then. We'll do 20 and we'll divide this now by 2.3263. And we end up with 8.59 and so on and so forth. So we can now write, and I'll do this to three significant figures, sigma will be equal to 8.60. So let's store that, and we'll now hit Shift, Store A. So it's in there. Okay, next one. We need to find the probability that the machine dispenses less than 110. So let's look at this. Probability that the volume is less than 110 ml. So again, let's make a substitution, and what we'll now have is a probability that Z will be less than 110 minus mu, which is 120, divided by the standard deviation, which we've got as 8.59 ... and so on. So let's work that out, and in my calculator, just considering this, that's going to give me minus 10, and then all I'm going to do now is put in here A. That's a value that we found, and this gives me negative 1.163 and so on. So round into two decimal places, it's going to be negative 1.16. So what we've now got then is the following. We've got the probability of Z being less than negative 1.16, giving us the value that we want. So if we now consider what we've got, let's draw a little line. So let's put it just here. Let's say it's going to be roughly about there. This is going to be negative, so let's put this on, negative 1.16. This is going to give us now the area to the left of the curve, or left of the line trapped under the curve, I should say. Now if we consider looking at this from the other way round, what we're going to have is our standard normal, and we'll have the point just here. This is going to be positive 1.16. The area that we've got shaded is to right of that. The table, standard normal table, will give us this value here. This value here is going to be phi of 1.16. Phi of 1.16 is the area trapped under the curve, just here to the left of this line or the right of this one. Therefore, if we want this, we simply do 1 minus phi of 1.16. So let's put in the calculator. So 1 minus, and all we got to do is find phi of 1.16. So 1.16, where are we? Just here. So we've got now, let's grab this up, 0.8770. So 0.8770. And this will give us this value. So what we can now say is that is going to be 0.123. Okay, so let's put that there. So what we end up with now is 0.123. In an exam, make sure you're writing a decent, setting this up decently. I'm kind of jumping a little around to try and save where I am or save some space of where I am to fit it all in. Make it logical, make the examiner be able to read what you're doing. Okay, 10% of customers complain that the machine has not dispensed enough liquid. We need to find the largest volume of liquid that will lead to a complaint, not need to a complaint, lead to a complaint. Okay, we can set this up like so. What we can say then is the probability now of V being less than some observed value of lowercase v will be equal to 0.1. This is 10%, 0.1. So what we're going to do is the following. We're going to make the substitution again, and I'm going to sub in now. Instead of v, we're going to end up here having z. So what we want to say is the probability that z is going to be less than this lowercase v minus 120, which is a mean, divided by our standard deviation, which is going to be 8.59, and so on and so forth. And we're told that that's going to be equal to 0.1. Let's consider that area right now. That area is going to be just here, and it's going to be now to the left of a line, trapped under the curve to the left of a line. That 0.1 though will come from our percentage points table. So this area now is going to be 0.1. Let's look at our percentage point table, and 0.1 gives us 1.2816. We have the negative equivalent. So this point right here, let's get down to it. This point now is going to be negative 1.2816. Remember, the percentage table, this gives us now the area to the right of a given value. So what we've got then, the area to the right is going to be 0.1 or 10%, and it gives us a value of z being 1.2816. Therefore, we need the negative equivalent. So all we need to do is set this up and solve a little equation. Okay, so what we're going to have is the following. We can now state, and let's write this up here, that negative, so let's write this here, negative 1.2816 will be equal to v minus 120 over the standard deviation, which is going to be 8.59, and so on and so forth. So I can now write v is going to be equal to 120 minus the 1.2816 multiplied by the answer stored in my calculator, which is 8.59, and so on, and this will give us the value we require. So let's do that then. All I've done is solve this basic equation for v. So what we'll have then is 120 minus now, and we'll have a 1.2816, and then what we'll do then is multiply this by a, which is stored in the calculator. 108.98, so 108.98 ... and so on and so forth. We will round this to 3 significant figures, and we'll say 109 mil. And remember, this is a real world application, so we do need to appreciate now that we've got 109 mil. So whilst the first ones were finding standard deviation and probability, in terms of your standard deviation, looking back on it, I think on that one we should put the mil. So let's just put that in. Because it is a real world application, find the standard deviation, it's going to be 8.60 mil. In terms of the probability is not going to have units. That's an oversight on my view. Make sure that has the mil on it, and make sure the final answer has the mil on it. So there we go. Nice testing exam style question on looking at normal distributions.